Hi, some of you may recall me coding this a couple of years back. It was in response to this challenge, and while my solution did the job, it still works today. But looking at the code now, I can't help but wonder what demon possessed me to do this, because there's no need for CSS blending, there's no need for masking. So let's code a better grainy gradient without all this shit. Okay, we'll be using a div with a fixed height and a radial gradient background. You're probably familiar with the syntax, but if not, don't worry. I'll be linking to a good article on the topic down below, meaning in the description box, not in the basement or in hell. Okay, so for now, we are going to produce the graininess, and we do that with an SVG filter. We're going to have an SVG element which is only going to be used to contain the filter producing the graininess on our element. It's not actually going to create any SVG graphics to put on the screen, so there's no need for it to occupy this space, which is by default 300 by 150 pixels. That is why we'll be setting explicit dimensions on the SVG. We're going to have width 0 and height also 0. Now, this doesn't fully solve the problem because we're still left with a bit of vertical spacing there, just like we have for actual images, unless we set display block or something like that on them. So something else I do in this particular case where I have an SVG that I don't want to see on the page, and I've zeroed its dimensions, right, height 0. I want to also take it out of the document flow, and I do this with position fixed or absolute. It doesn't matter, both do the job. Now, the interesting part, the actual filter. We're going to call this filter Grainy, and we're going to use it in CSS like this. Filter, URL, Grainy. Okay, this makes the whole thing disappear because we have nothing inside our filter. So let's start adding filter effect primitives. So we're going to have filter effect turbulence to create some graininess. And of course, I need to spell this correctly. But even if I spell it correctly, by default, with the default attribute values, this doesn't do anything. So we need to change, for example, its base frequency from the default to something that I can only describe as character vomit after the decimal point. So something like this. Okay? Now, something you should know is that here, we need to have this sort of character vomit value. It doesn't work with nice round values, so we can't have something like 2 or 5 or anything like that. And in case you're wondering why in Satan's name is that, what is happening in the back to cause this to happen, you know, not be able to have a nice graininess with a nice round number there? Well, I've got bad news for you. I wonder about that too, and I have no idea. I understand it's something like Berlin noise, and this is an article that got recommended to me. And I will say the one-dimensional case explanation does make sense, but then it goes to 2D and it completely loses me. I'll still be linking to it in the description. Maybe it helps you more than it helped me. Okay, but for now, we'll be sticking to what I've noticed through trial and error. Something else on that front is that if I decrease this number, then whatever you call this pattern here, because you can't even call it grains, it looks more like a cat played for way too long with a ball of yarn, right? This gets bigger, and it gets even bigger if I add another 0 there to make the value even smaller, right? You can see it like that. Now, as mentioned, this doesn't look like grains, and it looks more like grains if we switch from the default type, which is turbulence, to fractal noise. So type is going to be fractal noise. And this looks more like grains, but they're colorful grains, and we don't want these colors to influence our gradient. So we're going to want to grayscale this. Now, to grayscale this, we need to understand the HSL model. So HSL stands for hue, saturation, lightness, and it can be represented as a bicone. The hue goes all around the bicone. I'm having way too much fun with this. Now, let's explode this to better see the saturation and lightness as well. Now, the lightness goes from 0% at this end of the bicone, where we have pure black, right, to 100% at the other end of the bicone, where we have pure white. And in between, we have all possible grades. The saturation goes from 0% on the central axis, which is this axis going from pure black to pure white, to 100% on the bicone surface. So if we want to grayscale something, we need to bring the saturation down to 0. For this, we have two filter shortcuts in CSS. So saturate and grayscale. Now, saturate with a value of 0 is going to bring the saturation to 0, and grayscale with a value of 101 is going to fully grayscale something. But we need to do this in SVG. So in SVG, we are going to use another filter primitive, and this is going to be color matrix. Don't worry, we won't be using the default type of matrix, we'll be using type saturate. Okay, values 0. And this brings the saturation down to 0, and we have this grayscale graininess, which we are going to combine with our original element with this gradient, right? And we do this by using blending. Blending is a topic I've touched on in some articles and in some talks I've given, and I'll be linking to all of them. Basically, blending means combining two overlapping layers into one. We can combine more than two overlapping layers, but in that case, it's still done 2 by 2, okay? So we combine the bottommost two and then the result with the layer above them and so on. But in this case, we're only going to be combining 2 layers, and one is going to be that noise layer, the graininess layer, and the other one is going to be the initial element. So we only care about 2 layers. And in this case, it's done on a per pixel basis. So we take a pixel from the first layer and the corresponding pixel from the other layer, and we combine them using the blending operation, and we get the corresponding pixel in the resulting layer. This is how it happens. And for most blend modes, this happens on a per channel basis, or at least it happens on a per channel basis. Well, it does happen for most blend modes. It certainly happens on a per channel basis for the blend mode we'll be using today, which is going to be multiply. Okay, and for this, the channel values are going to be in percentage channel values in the decimal representation. Now, it's a bit more complicated with naming because this is called decimal RGB, values from 0 to 255, but we'll be using the decimal representation of percentage RGB, okay? So just to get an idea of this, 0 here goes to 0%, 255 becomes 100%, and everything in between 0 and 255 is going to be in between 0 and 100%. Right? And 0 is going to be always 0, okay? 100% is going to be 1 in the decimal representation of percentage RGB, and everything in between 0% and 100% is going to be in the 0-1 interval, okay? So, yeah, basically this, right? For example, we have this value, and you can see how it goes to the percentage, to the decimal representation of the percentage. Now, for multiply, it's quite easy because we just multiply the channel values. So for each and every pixel, we take the red channel, right? And we multiply it with the red channel of the corresponding pixel in the other layer. And we get the red channel of the pixel in the resulting layer. And then we take the green channel, the same, and the blue channel, and we do the same. So basically, this is how it's done. And this is always going to result, using multiply, it's always going to result in something at least as dark as the darker of the 2 layers that we blend using this multiply blend mode. This is because multiplying 2 values in between 0 and 1 always gives us a value that's at most as big as the smallest of the 2. Okay? So let's go back here, and we are going to have another filter effect primitive, which is going to be blend. It's going to use mode multiply, as mentioned before. And let's talk a bit about inputs. This turbulence filter primitive doesn't take any inputs. It just spits out this random mess. This color matrix primitive takes 1 input, which by default is the result of the previous filter primitive. Okay, this blend filter primitive takes 2 inputs, and by default both are set to the result of the previous filter primitive. So in this case, what we're doing at the moment is multiplying 2 identical noise layers. And let's just comment out this for a little bit, and you are going to see just this desaturated noise layer, and now you're going to see it blended using the multiply blend mode with itself, and we get a darker, the same thing, just darker. But we want to blend it with the actual element that we apply the filter on. So we are going to set one of the inputs, it doesn't matter which one, in or into, doesn't matter because multiplication is commutative, okay? So this is going to be set to source graphic. And this way right? We are going to get this. Now let's increase this value to get finer graininess. And something else I want you to notice is that the effect of this turbulence filter extends outside the element's bounding box. And this is because the filter area by default extends outside the element's bounding box. Something that makes perfect sense for something like a drop shadow, because we don't want the drop shadow to only be painted behind the element we set it on and, not outside the element where we can actually see it. But in this case, we want to restrict the filter area to the element's bounding box. And we do this by setting its top left corner to 0, 0 instead of the default -10%, -10%, and its dimensions to 100%, 100% instead of the default 120%, 120%. Because by default, we go from -10% to 120%. Not what we want in this case. So we're going to set top left corner x0, y0. And the dimensions are both going to be 100%. Height. And in case you're wondering, wouldn't it be better to do this from the CSS, for example, with something like overflow hidden? Well, no, because one, overflow hidden doesn't work. Overflow hidden hides everything of the element's content that overflows the element's padding box, but it does nothing for graphical effects on the element, such as box shadows or filter effects. So overflow hidden does nothing. What does hide this filter effect outside the element's bounding box is something like clip path or mask. So for example, clip path inset 0, this is going to cut out everything outside the bounding box. And so it's going to be something like masking and also clip path polygon, but we're not going to go into that. The problem with this is if we have something like a box shadow, it also cuts out that one. Now the thing with box shadow, it's even more interesting, and you're going to see why the cutting out from the SVG is not a perfect solution either, but just in a moment. So now you can see there's no shadow. But now if we cut it out like this, you can see how the area the filter gets applied on, that 100%, it includes the element's area with the shadow area, which is really weird and not what we want in most cases. And it's something that can be avoided with a really cool CSS feature. But for that, we're going to need to switch to Epiphany, because unfortunately it only works in Safari. So let's get back to this. Oh, yeah, I should actually save it, right? That's why the changes didn't apply in the live version either. Okay, so you can see there's the shadow and we still have graininess outside it. But we can avoid this if we don't use that filter like that. But unfortunately, this doesn't work with gradients, so we're going to need to use an image. So we're going to have something like this. Okay, so let's go back and get an actual image to use right here. Okay, and this is going to be inside a filter function, which takes two arguments. The first argument is going to be the image, and the second one is going to be the filter, which we're going to take from here. Yeah, I'm going to need to comment out that gradient. That's why it wasn't working. So now you can see, let's make it black. Perhaps it's more visible, right, like that. Okay, so you can see how now we don't have the graininess spilling out. And something else that's really cool when we have support for this filter function is that the text doesn't get affected, because here, let's go back here, and let's take all this, right, and like this, and let's say we're going to want to have a bit of text right here, and let's say we're going to have color white, right? You can see the graininess also gets applied on the text. But if we have this filter option, let's just copy this, and let's go to, no, presentation. Okay, and let's replace the background with that, and let's get rid of the filter, because we're also applying a filter on the whole thing. And you can see how now the text isn't affected, right? The box shadow isn't affected either. This is just so nice and so useful. And of course, we can get around these problems, right? We can use a pseudo element right here. So let's say that we are going to have before, right, content, because otherwise nothing is going to show up. We're going to absolutely position it, and for this we need to also set position relative on its parent, right? We're going to make it cover its entire parent in set 0. This is a shorthand for top 0, right 0, bottom 0, left 0. Okay, and then we are going to take this, and we are going to put it right here, and we're also going to take this and put it right here. Okay, and now you can see how the pseudo shows up on top of the text. So we're also going to need to set, okay, so we bring it below, right? And this looks nicer now, but of course it takes a lot more work than right, and it takes having this pseudo, it takes having position relative there, right? It's not ideal. Anyway, I'll be stopping here. There are bugs open. So for Safari, there is this bug that I opened because the filter function doesn't work with CSS gradients. So for example, if here I had the gradient instead of the actual image, right, if I had it instead of this actual image, let me just show you, replacing the image with the CSS gradient, this doesn't work anymore. So I've opened a bug and I can see there's a fix, but I'm not seeing it. It's true, I am on Linux, so I'm testing Safari stuff via Epiphany. If you have access to the latest Safari technical preview, let me know if the filter function now works with CSS gradients as well as with actual images. And there are also bugs open for implementing the filter function in Chromium and in Firefox, and you can star those, you can comment on those with other use cases, because I find that it would be really useful in this case and in some other cases that we'll be discussing in future videos. But I'll be stopping here, and I know you might be thinking, well, we started with a grainy gradient blob. Well, we'll be leaving that for another video, okay? But for now, I'm done. I hope you've enjoyed this video, and if you have, if you like the work that I'm putting out for over a decade now and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation. Or you could at least share this to show the world what can be done with CSS these days and SVG, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and I'll see you next time. Bye!